Now coming to the part three. Here we can explain. I can explain. I'm explaining about the LSTM neural networks. LSTM means like long short-term memory. In this, like I am explaining in the question three in 3.1, I am explaining the vanishing gradient problem and and the exploding gradient problem. In coming to the LSTM, I have written the shortly here. And the long short-term memory neural network was introduced in the mid 1990s by German academics Sepp Hoster and Georgian Schudenhuber as a solution to the vanishing graduate problem. The LSTM network was maintaining the mistake through the time and layer, resulting in the more consistent of errors. The neural network which has clear identification, and you can see a diagram. And coming to the cells is state and gates of the core concept of the LSTM. Here I am explaining about that LSTM neural networks. Two most significant concepts are cell state, C state, and gates. These are two types. LSTM can compensate from the indications of the simple RNN included by vanishing graduate problem in short-term memory. And here you can see here cell C state. Now coming to the cell C state, LSTM cell. In addition to the hidden state or hidden state, the LSTM cell has C cell or cell state because there is a no weight linked with the cell state that have the same thought numerous layer in the one or two steps. Any later time step can employ information carried from the previous cell state without any decrease. If the information is still excellent, relevant, and meaningful, it should be. And being see the route for transmission of information, we can see here two diagrams here, LSTM cell C and LSTM cell C state. You can see the difference. And the cable of the transforming data from the earliest time steps to the end of the sequence chain and can help with the short-term memory issues also. In the addition to the hidden edge state being the portion neural network memory, and you can see a diagram. And coming to the channel flow, the information can travel freely along the channels and it goes freely to the channels without being any slowdown and being to the conclusion. And the next one is a snapshot for a cell state. The cell C state has an ability to memorize the information in the cell at any time, any step, regardless for how early in the sequence is it. All local minimum plot and record weight and basis. We will have the numerous sets and neural networks which we have more precious short terms amount the time. And before the discussion, we may have the enable the aggregate and average these different networks to arrive at the more general opinions and as more move along the plots. At the conclusion of the walk, we will have the collection of neural networks. That is if you have many minimums, we have the multiple combinations of weights and basics with the network make less mistakes as a result. Any minimum weight may be viewed from finally work. So it has four steps. Has in the following information, LST cell has the four steps. LSTM cell has the four steps. And the first one is the forgot the gate, and second one is the fill in the blank with the gate, and the third one is the active the output gate, and the fourth one is active the output gate and the output gate. And coming to the forget gate, it has determined whether the information from the processed cell L should be eliminated as a formula. And in the second, it has the fill in the blank with the gate determines that inputs of HT minus 1 and XT is useful. We should be included in the whether new current cell C state, C of T, and the following steps. We active the output gate at times step T, compute the reactive new current cell state as well. In the coming to the last step of output gate, it determines which inputs st minus 1 xt as well new current cell of C of T. This is the diagram you can see here. And coming to the next like powerful solution with the vanishing graduate problem, it has assumed the network graded output y and also expect the network of the y as the loss is insignificant. The network makes the numerous errors. And coming to the next one, back propagation in the feed forward neural networks, FNN. You can see the diagrams, all of these. These are all the formulas and diagrams of the 3.1. Coming to the 3.2, and we are discussing about the limitations of similar RNN neural networks, and is there some disadvantages training RNN, the vanishing exporting graduation problems with the slow and complex training procedure also. Coming to the introduction here, like the introduction for RNN. Below we has some like excellent applications like music generation, systematic classifications, name identification, and mission translator. And we can training of RNN diagrams. You can see here the diagrams with block diagrams with the stand for blocks. And coming to the next, the vanishing of the expert graduate problems. You can see the like I will explain the each and everything in the simple manner. And the next one is exporting gradients, and RN cannot be and a slow and complex training process and the procedure of the slow and complex. You can see here. And the difficulties of process longer sequences. And as a discussion earlier, we bit different of training RNA is not longer sequence, especially while using the redundant training. It has another reason for the GR based networks. And at the conclusion, well, coming to the conclusion of 3.2, and we can usually generally have helpful to make the RNNs varied things possibilities like voice assistants and music. However, it should must be a resolved and graduate clipping of a network example of solutions now being with business. What if the fundamental structures changed and RNN family? And the next one it like is in a 3.3, and expanding the LSTM neural networks can provide the powerful solution with graduate problem. And I can explain the each and everything in the LSTM regarding LSTM, and you can see the diagrams of the as the formulas of the formulas. This you can see here is the diagram network cells of the cell of LSTM. You can solve like this. All the formulas and diagrams of the LSTM. Coming to the part 4, here we can I can explain that LSTM with the time series data. About the time series data, here the input layer, hidden layer, output layer. To the 4, there are several different series. First, we need to import the basic libraries and the matplotlib used for the visualization. We'll use the specific time series RNN, drop the fully connected the layers, and also, and with you by using need to import the keras. From that we use the time series generator to generate the time series inputs. We also need a min max scaler for scaling the data. We need to have the some data to with some simple RNN, and it should be a sequence. It is a time series sequences. Here I am using the stock data. The stock has made data points, and it has, and also like input all the libraries and everything in the Jupyter notebook. And you can display here clearly like 2582 shapes and the 7 attributes. All the attributes are variables. The volume is decreased as the integer, and the statistics and the numeric attributes the minimum deviation of and max. You can see here briefly exploring the data analysis EDA with really accurate, and we will get the here we will get the accurate data. Here we can perform the one time series. It would be a index from the zero, and it is a like a wavelength of the like with a graph of the RNN, and we creating the time generate training everything we like the screenshots and everything here. So the next all the graphs and here the percentage of testings and all this of and coming to the part 4, raising the neural networks, redesigning of the neural networks. And here we can redesign the other neural network with the importing the keras and all. And here's the you can show that the how I determine the quality of flowing prices is here. And also like entire I see time series inputs compare 60 entities, and has the data points with the data points like 3020 it should be have, and it has a 60 50 historical data points and predicted. These are like graphs, creating the time series, and also here, here you can see the time series for the forecasting. And here you can see the data set stock price data and the percentages and everything you can see here. Compared to the coming to the part 4, you can see the comparing the network performance here. I can discuss all of these then briefly. And coming to the part 7, project report. It's a project report, and it should be like brief introduction about the project report. And also I presented the video. That's it. And I explained the each and everything regarding the project in this report. So and also like I put the screenshots and everything which I used in the like which I used everything screenshots and everything I mentioned here. So thank you so much.